Okay, 12 divided by 15. What can I divide into both of those? 3. So 3 goes into 12 4 times. 3 goes into 15 5 times. All right, I'm dividing. What do I do with the exponents of, subtracting. Top minus bottom. So I get 4 over 5, a to the negative 2. Negative exponents, what should I do? Flip it. So instead of a over 1, it's going to be 1 over a, which means that a is going to be in the bottom. Still squared. It's just now a positive 2 instead of a negative 2. Now I can put the 1 on top, but you're going to multiply them anyways. Question? All right. This one, there's 2 different ways you can do it. You can do what's inside the parentheses first, simplify as much as you can, and then square it. Or you can square it and then simplify. I don't care which way you want to do it. Square it and then simplify. So if we square it, this squared goes with everything inside the parentheses. So you have, don't forget, there are little ones there. So you have a 3 squared. And then what do you do with the numbers?
Add them together.
And when you raise a power to a power.
I thought you were talking about
Oh, yes, you're right. You multiply with the exponents, I'm sorry. Yes. So that would be a to the 4th and b to the 6th. You're multiplying the 2 times the exponent. Sorry, I didn't ask that very clearly. And then 5 squared. A, remember that's a to the 1st. So it's a squared and b to the 4th. So far, so good? Okay, what's 3 squared? None. 5 squared? 25. Then we subtract exponents. So it's a to the 4 minus 2. And you can do this in your head without writing it down. I'm just doing this so that I don't lose anybody. And b to the 6 minus 4. So you get 9a squared, b squared over 25. Nine over 25 does not simplify. If I had ended up with a negative exponent, what would have happened? Yeah, I would have to flip it. This just means it would go in the bottom of the fraction. Or if there was a negative one and it was in the bottom, it would go in the top. You're right, you just flip it. Okay, let's do 5 the same way we did 4. So I know it's a negative, and everything in this is probably wanting to flip it. But let's not flip it yet. Let's go ahead, get rid of, multiply through by this exponent. And then at the end, when I have negatives, then we can flip it. So remember, when you raise a power to a power, you multiply. So Berkeley, tell me what the top's going to be.
X negative to the negative 6.
Uh-huh.
And then y
To the 9th, yep. And on the bottom, Hazella?
X to the negative 15.
Good.
And the y to the negative 6.
Good. Okay, now we have negatives, that's true. But let's do everything else first. Usually the negative is the last thing you do. So when I divide, what do I do with the exponents? Subtract them. So it's x to the negative 6 minus negative 15, and y to the 9 minus negative 6. So minus a negative really means plus positive. So it's going to be x to the, good. And again, minus negative is plus positive, so y to the 15. Notice I didn't end up having to flip a thing. Now, if we had done some flipping at the beginning, it still would have worked out. You just would have ended up flipping again. But it was just easier if you just try to hold off and do any negative exponent stuff at the end. Okay. So if I raise it to the 2/3, what does that mean? What kind of root? It's a root. It's a cubed root of 8x cubed over 27y to the 6th squared. Now, when you're taking the cubed root of a fraction, that means you're really taking the cubed root of the top and squared and of the bottom. Now, without a calculator, we can take a cubed root. We just break it down. 8 breaks down into, notice, 3 2s. So that means the cubed root of 8 is 2. The cubed root of x to the 3rd. X to the 3rd means x times x times x. So the cubed root of that is x. With exponents, really, you just divide those. So you just 3 goes into 3 once, so that's x to the 1st there. So it's a cubed root of 27. 3, because 27 breaks down into 3 times 9. And so it breaks down into 3 3s. And cubed root of y to the 6th. Yeah, y to the 2nd. 6 divided by 3 is 2. That's where it comes from. We still have the squared. Then we just square everything. 2 squared, 4. Raising a power to a power, that's x squared. 3 squared is 9. And raising a power to a power, that'd be y to the 4. They're not like terms. I can't reduce. I'm done. You try 7. Very similar to one we just did, only it has a negative. But again, you don't have to really worry about the negative until the end. Or you can do it again. It doesn't matter. However you want to do way, if you want to get started on your homework so you don't have it all at once, you can do, I think it's the first 6 problems are basically what we've been doing. Day 48, yeah. Obviously you don't have to yet, but I'm just letting you know. I'll be honest with you, I would go ahead and flip it since there's not a whole lot inside there. You don't have to, you can flip it at the end, but there's no negative exponents or subtraction that's going to make that negative go away. Notice I don't flip the exponent. That's a lot of people try to do that. You flip what's inside the parentheses. I don't flip the 3 over 2. The negative just means I flip what's inside. And again, you didn't have to do that first. I just want to make sure, I want to get done with this before the bell ends. So 2 is on the bottom, so that means it's a square root of 16a to the 4th. Don't forget the 3rd is still there. Square root of 25. I went ahead and just separated it. Do we just know the square root of 16? 4, yeah. And square root of a to the 4th? Yes. Remember, you're dividing. There's a little 2 here. 4 divided by 2 is 2. Still cubed. Square root of 25. 5. Again, still cubed. Now, these are not as easy to come by. 4 cubed is 4 times 4 is 16 times 4 is 64. And you could work that out if you needed to. And a squared raised to the 3rd means you multiply those. That's a to the 6th. Does anybody know what 5 cubed is? 75. Ooh, that's 5 times. 125. 5 times 5 is 25. 25, you were doing times 3. 25 times 5 is 125. And you know, just like all tests, you'll have one that's part calculator and one that's not. So. Okay, we'll stop there.